We're taught that reality works a certain way. The past causes the future. Time moves forward. Distance matters. Physics disagrees. These are 10 times reality slaps you in the face. Hard. When we're young, we learn something so basic it feels unquestionable. Causes come first, effects come second. That's just how reality works. Except, physics has a problem with that. Because at the smallest scales of reality, there are experiments where what you do now appears to help decide what happened then. Not time travel, not messages sent to the past. Something stranger. Imagine this. A single particle is fired into an experiment. Nothing dramatic, nothing sci-fi. But instead of deciding how to measure it straight away, you wait. Only later, after the particle has already done its thing, you choose what kind of measurement to make. And in some real quantum experiments, that later choice seems to determine what the particle did earlier. It's as if the universe refuses to fully commit to a history until it knows what question you're going to ask. Physicists have a name for this idea: retrocausality. It doesn't mean you can change the past. You can't rewrite yesterday's newspaper. You can't undo your own birth. You can't fix a bad haircut from 2009. But the idea that the past is completely fixed turns out to be an assumption, not a law. At the quantum level, reality doesn't behave like a finished story. It behaves more like a draft. Until something is measured, the universe seems perfectly happy keeping its options open, even about what just happened. So instead of the past causing the future, physics allows something far more uncomfortable. The past and the future may be mutually dependent. Not locked, not settled, but negotiated. And if the idea that the past isn't quite real yet makes you uneasy, good. Because time itself is about to get much stranger. There's something even stranger hiding in physics. Something that makes time and distance almost meaningless. Light does not experience time, like at all, not a nanosecond. From our point of view, a photon can travel for billions of years. It can cross galaxies, drift through empty space, survive the lifetime of stars. But from the photon's point of view, none of that happens. A photon is born and absorbed in the same instant. No journey, no duration, no distance. Imagine a star exploding 10 billion years ago. That light travels across the universe and eventually reaches your eye tonight. For you, that light crossed unimaginable distances. For the photon, creation and absorption were the same moment. This isn't philosophy, it's built into relativity. As something moves faster and faster, time slows down relative to everything else. At the speed of light, time stops entirely. Which means, from light's own perspective, the universe collapses into a single point. This doesn't mean light is conscious. It doesn't mean photons are experiencing reality the way we do. But it does mean that time and distance, two things that feel fundamental to us, are not universal features of reality. The universe you experience is only one way reality can exist. And if the idea that some things exist outside time itself feels strange, then what follows is very cool. Literally. Sometimes, reality doesn't need deep space or extreme physics to break your intuition. Sometimes it does it with a glass of water. In some situations, hot water freezes faster than cold water. That shouldn't be possible. Cold water is already closer to freezing. Hot water has farther to go. And yet, Over and over again, in real experiments, hot water freezes first. People have tested this for decades, in classrooms, in laboratories, in ordinary freezers, and it keeps happening. This isn't a trick. It doesn't happen every time, and it depends on the conditions. But when it does happen, it completely breaks common sense. There are explanations: evaporation, convection currents, dissolved gases, changes in how water molecules organize themselves. All of these probably play a role. But here's the uncomfortable part. There is no single explanation that works in every case. Physics agrees that it happens. Physics argues about why. Which means even something as ordinary as water can behave in ways we don't fully understand. Not at the edge of the universe, not at extreme energies, but right there in your kitchen.
Thanks for watching. Dark Beacon is still a tiny channel, and every interaction helps more than you know. So please leave a like, and I always respond to comments. Now, let's continue.
Here's something that feels so obvious we never think to question it. Right now. This moment. It feels universal, but it isn't. There is no single shared now in the universe, not one that everyone agrees on. We tend to imagine time like a giant clock, ticking forward, the same for everyone, everywhere. Physics disagrees. According to relativity, whether two events happen at the same time depends on how fast you're moving. Imagine two lightning bolts strike at opposite ends of a long train platform. To someone standing on the platform, they happen at the same time. But to someone on a fast-moving train, one strike happens first, and the other happens later. Both observers are correct. There is no deeper answer, no hidden true version. Simultaneity itself depends on motion, which means the idea of a universal present moment doesn't exist. What is now for you is already the past for someone else, and still the future for another. Even if you're standing right next to each other, the universe does not agree on what is happening right now. There is no master clock, no cosmic present, just different slices of time depending on how you move through space. And this effect doesn't just exist in theory, it gets stronger with distance. The farther apart two events are, the more their now can disagree. At everyday distances, the difference is tiny, barely noticeable. But across cosmic distances, it becomes enormous. For observers separated by light years, what counts as now can be separated by years, by decades, even by centuries. An event that is happening right now in a distant galaxy can already belong to the past for one observer, and still lie in the future for another. There is no contradiction, no mistake. Time itself does not line up across the universe. The universe does not agree on what is happening right now. There is no master clock, no cosmic present, just different slices of time depending on how you move through space. Here's one of the strangest ideas ever discovered about reality. You cannot tell the difference between gravity and acceleration. Not sometimes, not approximately, ever. Imagine you're inside a sealed box. No windows, no instruments, no way to look outside. You feel a force pulling you toward the floor. Your feet press down, objects fall. Everything feels normal. You might think you're standing on a planet, but there's another possibility. The box could be an empty space, being pushed upward by a rocket. From the inside, the two situations feel identical. There is no experiment you can perform inside that box that tells you which one you're in. Gravity and acceleration are locally indistinguishable. That's not a coincidence. That's the core insight behind general relativity. What we call gravity is not really a force pulling you down. It's the result of moving through curved space-time. Standing on the ground feels the same as accelerating upward because, in a deep sense, it is the same. The universe doesn't care whether you're falling or being pushed. It treats both situations as equivalent. Which means one of the most familiar forces in your life isn't a force at all. It's geometry. Here's a question physicists have been chasing for decades. Why do the laws of reality have the values they do? Why these particles? Why these forces? Why this universe? What if the answer is, they didn't have to be this way? In some versions of modern physics, the equations don't lead to one solution. They lead to an enormous number of possible solutions. Each one describes a different way a universe could consistently exist. Different laws, different constants, different realities. And the number of these possible universes isn't small. It isn't millions, it isn't trillions. It's something like 10 to the power of 500. A 1 followed by 500 zeros. That's more possible universes than atoms in everything we can see. This idea comes from string theory. It isn't experimentally confirmed, but it falls directly out of the mathematics. If the theory is right, then physics may not be searching for the laws of reality, but for which set of laws we happen to live in. The universe you experience may not be necessary. It may be one randomly selected option from an unimaginably large menu. Not chosen, not designed, just allowed. After hearing that physics may allow an enormous number of possible universes, it's natural to ask something unsettling. Why do we live in one that works? Why does this universe have stars, chemistry, complexity, and life? What if the answer is simpler than it feels? We only ever find ourselves in universes where observers are possible. That's it. No purpose, no intention, no design. Imagine 100 people standing in front of a firing squad. The guns fire. 99 fall. 1 survives. That survivor might think, the odds were incredible, something special must have happened. But from the outside, the explanation is obvious. Only survivors get to ask questions. The same logic may apply to the universe. Most possible universes may be sterile. No stars, no chemistry, no structure, and no observers to notice them. Uninhabitable universes are silent forever. So the fact that this universe looks finely balanced for life doesn't mean it was designed that way. It may simply mean this is the only kind of universe where anyone is around to notice. The universe doesn't look habitable because it had to be. It looks habitable because only habitable universes get observed. We tend to think of time as something that flows. The past is gone, the future doesn't exist yet, and the present is what's happening now. But physics offers a very different picture, one where time doesn't flow at all. In this view, the universe is not a process, it's a structure. Past, present, and future all exist together, equally real. This is called the block universe. Instead of reality being created moment by moment, every moment already exists. Your birth, this moment, your last moment, all part of the same four-dimensional structure. Nothing is coming into existence. Nothing is being destroyed. Time is not passing. You are moving through it. Imagine your life as a complete line. Every experience already laid out, not changing, not updating, just there. From this perspective, the future is not open in the way it feels, and the past is not gone. They simply exist at different locations in time. The feeling of time passing may be a feature of consciousness, not a feature of the universe.
We take something for granted without ever questioning it. That space separates things. That here and there are fundamental features of reality. But what if they aren't? What if separation is not built into the universe, but into the way we experience it? In our everyday world, distance feels absolute. Objects are either close together or far apart. Space seems to divide reality into distinct pieces. But modern physics hints at something far stranger. At the deepest level we can probe, some systems do not behave like separate objects at all. They behave as a single system, even when spread across space. Nothing travels between them. No signal, no message, no hidden connection racing through space. They don't influence each other across distance. They were never separate to begin with. Quantum entanglement is one example of this behavior, not as a curiosity, but as a clue. A clue that space may not be what makes things distinct. If that's true, then distance is not fundamental. Here and there may be approximate ideas, useful at human scales, but not written into reality itself. At the deepest level, the universe may not be local, not divided into places, just connected.
Some physicists are beginning to suspect that space itself may not be fundamental, that it isn't part of reality's deepest layer at all. Think about the screen on your phone. The icons look solid. They appear to sit in space. They respond when you touch them. But none of that is what's really happening. Those icons hide layers of circuitry, signals, and processes far too complex to interact with directly. They're a user interface, a simplified way for a human mind to survive and function. Now imagine that our three-dimensional world works the same way. Space and time may not be what reality is made of. They may be how reality chooses to appear to us. A perceptual desktop. Useful, reliable, intuitive, but not fundamental. If that's true, then the universe we experience isn't the underlying system. It's the interface. We're not living inside the universe. We're looking at its desktop. And the trouble with desktops is that they can be shut down.